And here we are, absolutely punctual, 1400 hours exactly. Welcome back to session 3 of this DBX EU MODEX conference on marine pollution. And I can tell we've got emergency responders here in the room because everybody is where they need to be, when they need to be. Hope everybody is feeling fortified and that everyone here in the room has had lunch and that all of our virtual viewers have also been able to have some sustenance, because we do have quite a bit to get through for the afternoon and a lot of very interesting presentations. This morning we were able to really sort of collate a lot of the results that you accumulated over the last 3 days in a number of very fruitful presentations. We also got some face-to-face feedback from experts on applicable real-life scenarios. And now what we're going to do in this third session is that we're going to look at new developments and technologies in the field of marine pollution, with particular focus in this session on the implications of the IMO's low sulphur fuel mandate for cleanup efforts. As you all know, there was new legislation as of January the 1st in 2020. And that is appearing to have some unintended consequences that weren't to be expected. There was also a lot of talk in the last session about the awareness or lack of awareness of support that's available from the EU mechanisms. And so it's rather fitting to start with a presentation from EMSA, which is the European Maritime Safety Agency, which works on maritime safety, security, climate and environment, a lot of single market issues, and positions itself as a very essential partner and player in the within the maritime cluster here in Europe. Victor Diaz Seco is a senior project officer at EMSA in the Sustainability and Technical Assistance Division, and he's here to tell us today about EMSA developments to respond to new threats by HNS, low sulfur, and alternative fuels. Please give him a warm welcome.
Thank you. Good afternoon. Thank you very much. So, in the past days, we have been looking at the existing capacities that are available from EMSA in order to support pollution response actions of the member states. Today, I prepare a few slides that will look into the future, into the current and future challenges that we can expect in the response to marine pollution incidents. And on that, I have okay. I have considered the challenges in the response to HNS, low sulphur fuels that were mentioned here, and new alternative fuels which are coming up to the market, and to present a quick overview of activities that we are now implementing within our current mandate and budget, and activities that have been or are the result of a consultation at the technical level with the member states in order to identify the actions that we could implement from a technical perspective, and activities which have been then agreed at senior management level and at the administrative board of the agency. I wanted to stress these 2 points because we work on a bottom-up approach, or we follow consultations with the users of the services, the member states, but of course we don't implement our activities based on our judgment. All our activities are endorsed and approved at the administrative board of the agency, who is the organism or the entity that has the power to implement or to agree on these new actions. So starting with HNS, we had, as I said, several consultations with member states. We explored different options, which included equipment for personal protection equipment, sensors, remote sensing, etc. So it was decided that as a first step, moving to operational response in HNS, because as you know, so far we have focused our activities in HNS in information services, MARAES, MARSIS that we have seen these days. So this is the first element or with an operational concept that we are in the process to build. It's a new capacity, which is response equipment for chemical cargo transfer lightering. It is somehow the result of lessons learned in some emergencies we had in 2021 in Bulgaria, supporting the Bulgarian authorities after the grounding of the Verasu, which was with a cargo of urea. We provided barges, which were used for lightering of the ship. And urea is not a corrosive or dangerous chemical product, but is classified as HNS. So what we intend is to complement existing capacities available from us, like these barges, with a portable emergency offloading and transfer system. We have launched a procurement, which is ongoing, and if successful, we will deliver these systems to our stockpiles, like the one that you visited here in Porvoo. They will have this set, which will comprise air-operated double diaphragm pumps and air compressor with some ancillaries to make it operation autonomously. A second line of action with regard to operational response to HNS is operational training. So it was identified in discussion with member states that there was a need and it was a willingness for us to move in that direction. It was presented in October at our meeting, the Consultative Technical Group for Marine Pollution Preparedness and Response, with member states, a proposal in order to develop operational training for the response to HNS incidents. It was well received, and we asked them for nominations from member states in order to build a consultative group in order to start evaluating the training needs analysis to develop a set of competences which will end up in the design and development phase of the training. 16 experts have been nominated in this correspondence group, and we will have the first meeting in March, and then what will be the training needs and what will be the learning outcomes in terms of skills or competences will be, of course, the result of these discussions with the correspondence group, for which we will use our EMSA Academy to support the whole training process. Okay. A third development that I wanted to share with you, it is the so-called oil spill response operations simulator. This is a complex IT project. We started in 2022 with the feasibility study that it was completed, where we review existing oil spill models and similar tools through a comparative analysis, methodologies to account the efficiency of all response operations at sea, and propose options for the definition of functional and non-functional and technical requirements on the tool. So this was completed. The tool is somehow the result of or the outcome of the stress tests that we implement in 2019 and 2020 at different regional sea basins, where we use a response simulator that was not really state-of-the-art and did not address all the elements in oil spills. They had gaps that were, of course, identified by everyone. So we intend with this to create really a very strong tool that can be used by member states for preparedness activities, decision-making during response operations, a very complex project that will be developed in several phases. We are now in the process currently of the development of the specifications for the procurement of the software tool that will be developed in phases. And if everything goes as planned, we should have a strong EAS-based tool available end of 2024 or 2025. As I said, it has the complexity of integration of databases, weather forecast. I mean, it's a lot of elements, and therefore it will take time. But this is the feasibility study. It was completed, and we are now in second phase. Regarding response to low sulfur fuels, we had that in the exercise. Actually, the EU Neptune had a cargo with a very low sulfur fuel. I will not enter into the details because my colleagues in the following presentations will tell you much more about what's going on about it. But from our perspective, what we are doing is to follow up on certain research projects like the IMAROS project and any innovative solutions that may come up in the market. In the meantime, what we are doing in-house is rethinking the potential of existing equipment that we have in our vessels, in our stockpiles, and see if there is any means of having a technical adaptation so that existing equipment can serve for the purpose, considering the different requirements and characteristics of the low sulfur oil. We are in consultation with equipment manufacturers currently, and pending the outcome of such discussions. For some of them, we have already some clear way forward with some small adaptations so that the equipment that we have at the moment, which is a state-of-the-art equipment, can also serve with a warranty in response to low sulfur fuels. Regarding new equipment or innovative solutions, we will wait for new and proven technical solutions in the market before considering procurement of new systems. And last but not least, regarding alternative fuels, this is part of the work of the area of the sustainability, and a number of studies have been developed and are being and will be developed in relation to alternative fuels and power solutions for ships. Over the years, we have already provided with a number of them. All the studies are comprised of three tasks that had to be accomplished on the state of play, regulatory analysis, and on a safety assessment. So for each of the substances of the studies, we implement these three tasks in the technical reports. I think of particular interest is task 3, which is about hazards analysis and identification. We are thinking about response or how to address spills from these new alternative fuels. And we ask the contractor to perform in these reports analysis on the different ships, traffics, to identify the risks associated with the fuels and provide recommendations on how to deal with them. While so far the main outcome of the reports is that more research is needed, and I think we all can agree on that, because there are a lot of uncertainties, and we are not there yet to identify what we can do or how to deal with. There are already some examples and some lessons learned from these studies that bring some ideas, and therefore I have included in this slide the study of the ammonia that was a study released this year, where they found that for the non-ionized ammonia that does not dissolve in water, spraying with a mild acid could facilitate that more ammonia is dissolved. So this is, it's a small thing, but it's something that, along with more findings for more reports and more research, can pave the way of how we can address response, very challenging response to these alternative fuels. And with that, I think I have completed my time, on time, and thank you very much.
Thanks very much to Victor Diaz, and you can take a seat. Very well done, absolutely. And thanks for telling us, sort of laying the groundwork with an overview of those efforts on the part of EMSA to adapt, update, and review their toolbox and equipment, etc. And obviously the low sulfur fuels having been introduced, just one example of things that have been introduced to clean up shipping, but they behave very differently, so there are a lot of things to consider from a responder's point of view. And on that note, we are going to have a presentation about the IMAROS project, which Victor mentioned. That's an EU-funded project dedicated to improving response capacities and understanding the environmental impacts of these new generation low sulfur marine fuel oils when they are involved in a spill. So Torben Iversen is a commander of the Royal Danish Navy and represents Denmark in international forums related to these issues, and he's one of the founders of the IMAROS project. So he's going to tell us about new generation low sulfur fuels from the responder's perspective. The floor is yours.
Thank you.
Take it away.
That was a fast run-through. While somebody's making this work, luckily it's only, there it is, at least one of them. So I will move backwards now in my presentation. The reason for this is the MARPOL regulation on sulfur and NOx in the ship's exhaust gases, and actually started in 2015. So that was when there was a reason to look into how to solve this problem for the shipping branch. And they basically had two solutions. One was either to use a fuel that would be usable in an engine designed for heavy fuel, and then with such a low sulfur content that it was the exhaust would be within the limits. The other solution was if you installed a scrubber which cleans the exhaust gas and therefore does not put so much sulfur out into the atmosphere. And then with that regulation, then at a routine test carried out by the Norwegian Coastal Administration, they tested 4 traditional fuels, but also 2 new low sulfur fuels directly from the refinery, and they did that around 2016, 2017, and then 2017 they briefed us and told us that those 2 new low sulfur generation fuels, they could not be collected by mechanical recovery. None of the methods that had been tested were useful. That could not be dispersed, and you could only do in situ burning if it was August month and it was the southern Mediterranean. So basically that meant that we had no response option towards the low sulfur fuels. And that was a scary night to lie down at the hotel room and think about this. So we came up with this study that should look into those low sulfur fuels. Also, it turned out that at this initial test done in Norway, they were not, the toxicity of the low sulfur fuels was somehow unpredictable. So there was really so many uncertainties in this equation that we thought we better put at least identifying some of the factors. So we went out and I should say the first slide, that was actually a ultra low sulfur fuel oil spill at the east coast of Sweden in 2018. Car carrier Makassar Highway. It had bunkered in Far East Asia, and it also caused troubles when you had to respond to that spill from our Swedish colleague side. So it was a relevant issue, and in between, there's been an Arctic study, Arctic Council study, telling that the most used port for bunkering for ships going through the Arctic, that's Singapore. So this is worldwide business. So we started out with a seminar, and we had a briefing from the captain's perspective. We had a briefing from the bunker deliverer, and then we had BIMCO, because BIMCO is a professional bystander that could tell us what the other two parties either didn't know or wouldn't tell. And together that gave us a gut feeling that we should go into to this business. But we got one thing out of it already at the seminar. Oil is blended very much from the time that it leaves the refinery and until it reaches the end user. So the characteristics we had seen when we were just looking into this initial report from Norway, perhaps they weren't the same when we did a live test. So we started looking into those low sulfur fuels. Many people call them hybrid fuels, and that's because oils are following a standard called 8217 ISO standard. But this standard is not usable for low sulfur fuels because they are a mix of different types of standardization. So you could say that it's perhaps an HNS, a chemical, but still it's used as for propulsion. So this blending issue meant that we would not see the same product as we had been seeing in the initial tests. But this blending also means that it is sold in batches. So over the process, we had different steps where we asked for oil samples. And in fact, it could be that 1 month later you wouldn't get the same fuel as you got the previous month. So therefore, it also meant that we have to look at it from a more generic perspective and a lasting perspective. But this also means that for the captain of the ship, it's not like when you fill gas or diesel on if you have a fossil fuel car, because you would say, I fill it with Shell or Circle K or Exxon or BP or whatever it is. But this captain does not know the origin of his fuel. He can tell you where he bought it, he can tell you the price, and he can tell you which sulfur content he'd been promised. Sometimes also the flash point, but that's it. He doesn't know what he's using. So that is a vital lesson learned to take away from here, and that is, if the captain cannot tell you, then you have to be prepared on everything when you go out to respond to a low sulfur fuel spill, because the characteristics I'll show you shortly, they're very different, and therefore you have to be prepared for everything. So it's still not a good situation. Then we thought this started 2020. The market should have settled, but we wanted to make sure that it had settled. And I remember the biggest bunker operator in Northern Europe is Danish. We had a meeting with the operational director there. That was a Monday. The Thursday before, oil prices went up at Rotterdam with 35% and another 17% that particular Monday. So that meant that the market was swapping around. Where heavy fuel used to be the cheapest, it suddenly became more expensive than low sulfur fuels. So, and that swapped 3 or 4 times while we had the dialogue with the market. So then there was this issue about COVID. That changed the patterns of life for land-based human beings, and that also meant that the fuel prices had an effect on that. So there was it was not a good time to do a market analysis because COVID changed the trend, and what happened to the oil prices. But also we saw that the trends in Asia were very different from the trends in Europe. And the fuel procured in Asia caused problems with Makassar Highway I told you about, with Express Pearl, with Wakasio of Mauritius. So that may not be the same in Europe. But then we found out that actually the European market was not uniform either. Rotterdam and Antwerp had two different prognoses for where it would go with the fuel products to be used in the future. So local differences were at least something that was still a concern. And my statement here is that the market hasn't settled yet, and that's a reason to stay curious about what would happen. What we did was we went out to refineries and to bunker suppliers and to EMSA, to Victor, because EMSA runs a fleet of 16 vessels that are standing by to become response vessels, but they're everyday business when they're not collecting oil. Luckily, they're not so much of the time. That is delivering bunker or transporting oil. So they had insight that we could use. So we went out to EMSA, we went out to refineries in our nations, we went out to bunker deliverers and with a questionnaire and asked them about it. And we, based on the input we got in a questionnaire, we selected 15 oils that we did a chemical testing of, small-scale test. That small-scale test was only a 2-liter sample, and it was basic testing. But then we found out that we needed to do more chemical characterization, and for that we asked for a new sample. And some of the samples were already outdated. So we had to say, okay, then we want something that's representative for our purpose. And we found out that those low sulfur fuels have a very, very big variation in pour point. I think the lowest one was -27 and the highest one was +33, which would basically mean that the one with the highest would always solidify as soon as it gets out, while the other one, it has to be Finland in the wintertime before that would become solid. So that was the variety of pour point. Toxicity was it. The good thing is it was less toxic than we could fear. So actually the environmental consequences were not as high as we could fear. And that is really important when you think about that we may not be able to collect the oil once it gets into the sea. Then at least it's good to know that it's not killing us directly. And then another thing that we got out of the chemical characterization was that in France at Cedra they did a test where they put tiles that were representative for rocks on the coastline. They put such tiles, they put oil on it, and it penetrated the tiles. So for a responder, that's pretty bad news, because that means you cannot just clean the coastline and say, now we've been here. Because if you do that, then the oil may start leaving the rocks just 1 month later, and you have to clean it again. The good thing was that it indicated that if you had very hot water when you cleaned up the tiles, then you could actually get the oil fluent and get it out of the tiles. But it'll be a new dimension in the response strategy for shoreline responders. And then we had also support from the Belgian Institute of Natural Sciences, and they did tests against with the generally known and highly accredited modeling tools for drift of oil to find out did this behave different from what we think of oils right now. And that is, of course, like if you look at the pan, water would not behave in the same way when you turn on the heat as oil would on the pan. So if this oil that is not oleophilic and does not stick to anything, if that also, because of the mix-up with water molecules, would spread differently. And there were also some findings on that. Picture down there is Wakasio, VLSFO oil, a big problem. Luckily, that wasn't that toxic because they didn't have PP equipment when they cleaned up in Mauritius. It's not that cooperative. There it was. So we did response tests. They were done, carried out by the Norwegian Coastal Administration and CEDRA in France. In situ burning, that was not an option. We were at this time of the project working with 4 representative oils. None of them, you could say that it's a doable solution to do in situ burning. The dispersibility was poor, so that is not something we should calculate or rank really high in our efforts. And then the oils with the highest pour point caused us severe problems. That one on the picture is the one with 33 degrees pour point, and it's not because there's so much oil. That is like if you put a skimmer, that type, next to the ship that's leaking. The skimmer didn't even go into the water. So therefore you could not collect that oil. When it was the one with a pour point of 27 degrees, then it was so sticky that it couldn't get into the skimmer. So that one, it wasn't recoverable either. So the other 2, they were, let's say, that it had some effectiveness with mechanical recovery. But remember, we've only tried 4 products of mechanical recovery, so this may not be representative. So there's something to build on. So then we found out this thing about that you couldn't clean the coastline just in one process. You at least needed a lot of hot water. And then we found out that there was a low detection in the air measurements of this new oil. The aromas weren't that bad, and the aromas, it sounds so nice, but it's not if you look into the details. So therefore it was less frightening than we could fear, but still we do have some challenges because we don't have a clear picture on what we could collect, and if somebody has the golden nugget, that would really leave us somewhere. So we've done something, we've progressed quite well, but because of the unclear market trends, we still cannot tell what would be the major challenges and rank them in 2 or 3 years. So we're looking into a follow-up project, provided we can get funding from the mechanism, because there are still some uncertainties. But we also need to prioritize our project, and for you as responders, the most important thing will be that we will look into all the products that are available on the market as response in a cooperation with industry. That is one of the objectives, because that way we could say, okay, this one actually works, but that one doesn't, and find out what is it we need to do. So there'll be a broader and more close cooperation with industry if there's money for a follow-up project. And then we only looked at SOx and NOx, but also this thing about black carbon in the new fuels. That would be relevant, because that is also a problem for our air and our breathing. And then the link between pour point elasticity and wax has some uncertainty when we're about to model the drift. And then we would like to include the shoreline testing because of the one thing with the tiles, but that was just one out of very many tactics. And for civil protection, then the shoreline is perhaps the most vital issue if we cannot handle it at sea. So therefore, it's hopefully to be continued, this IMAROS research, but still it's pending funding, and I have it's my assessment that there will be an application this year, and the findings will be briefed through appropriate forums for seagoing responders. It will be the CTG panel and the Pollution Response Services panel when we meet in Lisbon with Victor. Thank you.
Thanks very much to Torben Iversen for that presentation, and obviously a lot of challenges ahead with the proliferation of alternative fuel types. So a reminder to our audience, both physical here in the room and also to all of you out there in the cyberspace joining us over YouTube, to get your questions in. And a reminder that we are using the Mentimeter conference tool, so go to mentimeter.com or scan the barcode or use the link in your chat for those of you sitting at home, and then you can enter your questions. And we really would like to see them start coming in, because we've got a lot of really, really technical information, obviously, that is going to inspire a lot of questions, and don't be shy to pose them, please. We will take some time for those. Well, next up we're going to hear, after hearing about the challenges with the fuels, we're going to hear from a firm which is one of the leading oil spill equipment and service providers globally, and Victor had also mentioned the problem of sort of reviewing equipment. Markus Nystedt is the technical director at LAMOR Corporation PLC. He's here in Porvoo in Finland, and he works with oil response equipment in terms of the manufacturing, testing, developing, and training, but he also helps in terms of implementing that in real time, in real life spills. So he's going to talk to us about the challenges in recovery of these low sulfur fuels. And please give him a warm welcome. The floor is yours.
Thank you, Karin. Good afternoon, ladies and gentlemen, and happy to be here and present the topic of challenges in recovery of low sulfur and biofuel oils. So thank you for this opportunity. So I was asked actually to present of the challenges in here, and actually continuing a little of what Victor and Torben already said. And actually this IMAROS project had also been an inspiration for me in terms of the source and information, because there is not that much other than the IMAROS project itself. So that has been a good background for our studies as well. So actually, just a short recap of how I see it in terms of these different fuels. And I'm not going to go into the oil and the chemistry itself so much, but I picked a few things that will impact on the oil recovery. So as Torben already said, for the low sulfur fuel oils, from recovery point of view, one of the main challenges is then the solidification. So if you put in the skimmer in the oil, you may get a lump of oil into the skimmer, but after that one, the rest of the oil just stays put, and you won't get more in. Another one which we've looked into is this fossil fuels with ethanol, a mix of that one. We've seen, I mean, it's typically lighter products, not so much for the vessel traffic, but more for small boating, but even so an important one. And here we've seen a slight degradation in the recovery capacity because of this ethanol component in the fuel. It doesn't really, it becomes less sticky. So the oleophilic skimmers doesn't work. And I think here, actually, Justina from XAMK, they would have some more test results also here in soon future to show about that one. And then for non-fossil fuels and fuels and synthetic ones, here I do have very little experience of how they do behave. So here, this is a more gray zone for me. And I would say here also we have questions like, what will be the density of the product? Will it float or will it sink? Will it have the oily behavior or not? So I think this is an area also where we need to study more, and this is of course very much depending on what the source of the oil is. But kind of looking at what Torben also had here in that what recovery methods do we have and what works. So mechanical is the one I'm going to focus most on. We then have dispersing, which we heard already from Torben that it's not really effective on that one because of its solid state. In situ burning, again, I think the feedback or the understanding from IMAROS was that it's not really that effective either, and very limited use, considering that I'm not sure that we are even allowed to use that in our waters here. Absorbing, again, for small scale now, if we go from big scale to small scale, absorbing is a tool used quite a lot. But again, for this solidified fuels, then I see it. I don't have experience, but I see it unlikely to be successful. I don't think we're going to have much luck in this one. And actually now, what I'm mostly referring here is to the low sulfur fuel oils which are solidified. So as I think also Torben said, not all of them will solidify. So there will be a mix, and we will never really know which one it is. But the ones I've been looking on more is the ones that then would solidify, because the others, I am expecting them to behave in a similar manner than with traditional oils. I divided the recovery, so now I'm going to focus more on the mechanical side, and then divided it in 3 areas. So recovery from beaches. Actually, I learned something new today from Torben's presentation also about the penetration and how it sticks. So what Cedre has been doing tests there, that how it sticks to the rocks. I was assuming that it wouldn't be so sticky. So my perception would be that actually it may be easier for recovery on the beaches because of the solidified shape and not so much penetrating into the soils. But I may be wrong here, but that would be my guess on it, so that it necessarily isn't more complicated. So you may correct me if I'm wrong here, but this is my assumption. Containment, so for boomings, here I don't really see a big difference if we're talking about the traditional oils or the solidified oils. Actually, we may have a benefit of them. We don't have so much necessarily leakage of the boom. As we have a lighter product, we have perhaps a higher likelihood of leakage in the boomings, whereas with a more solidified oil, I see it less likely for leakages. But also I've understood there are some of these low sulfur oils that have a density which is close to water. So once gets a little mixed with water, we also may have a sinking oil. And of course, in that case, the boom is useless. Then to mechanical side where we have the biggest impact, and I think you also saw that in the IMAROS project, is then especially the stationary skimming. So when we put a skimmer into the oil and it more or less stays in position, that here is where we see a significant difference, that the traditional, may it be a disc or drum or brush or even a weir skimmer, that we will be able to collect whatever is perhaps just fixed or close to the skimmer, but as the rest of the layer, it's more solidified like a layer of thin ice almost, that even though you take off a chunk, the rest will just stay. So here is something where we need to do improvement. Pumping. So let's say that you would get up the oil in the hopper of the skimmer, then we still need to pump it. So again, if we have a very solidified oil, then we will have a challenge of how to get it into the pump. Suction pump may work, but again, we have frictions in there. But for getting it into the pump, so that's another challenge. Storage. If you have a vessel with heating tanks, it may be one thing. But if we're talking about temporary solutions, say a bladder or a barge, like the barges that Victor presented here, then once it gets solidified in that barge, what you do then? The barge is luckily, it's an open one, so you can, but from a bladder which is closed, then it may be difficult to remove, and we cannot really heat the fabric tanks. So that's a challenge. So then this was kind of the challenges, then looking at things that at least we have tried out or believe that may work. So we have at least had with the advancing systems some luck in recovery of oils which are more solidified. And I think also Victor mentioned a very key word there in his that not the station but the dynamic systems is that we are totally on the same page here, that with the dynamic systems we see a much bigger likelihood of them working. And not the dynamic or moving part itself, but we need also the skimmer to be very open and in the oil so that we can actually get the oil in. And we have a slight loss of the oleophilic skimmers will not work in the same way, as I think Torben mentioned as well. So we need to think about this more a combination of mechanical recovery, oleophilic recovery, and also this dynamic movement. For the sweeper systems, for example, I haven't now tried a sweeper system with this kind of oil, but one thing of a concern of me is that with the traditional oil, which is still liquid, you can build a layer, which is really the key point. You're going to sweep and then you're going to collect all the oil into a pool. But with a more solidified, I'm not sure that will the oil really build up as a layer, increased layer, or will it just be a big slick which will not get smaller. So here I have a little, I don't know, I don't have experience, but this is just on a thought that it may be some challenges there. Oil trawls, however, may have, once the oil slick the solidified oil would be a little scattered, then oil trawl may have an opportunity here to work. Again, nothing testing, nothing confirmed, but this is again based on a feeling of how the oil behaves for what I've tried. In icy conditions again, I think we have a bucket skimmer which is more or less a excavator bucket, where we can combine a skimmer. So with that combination, I do think we have a possibility to recover the oil, because in icy conditions, the benefit is that we have as long as we have ice around, we have something to push it against, so we can actually move it and try to grab it. Whereas when we are in open water, if you push the oil slick, we will just push it away. So there we do have some thoughts of it working. For the pumping point of view, we really see that heating is a necessity here. I think, as Torben mentioned, we are talking about a solidification or a pour point of up to 33. So when we hit the water, the increase of temperature for us to be able to pump it is not that great. We're not talking about heating it up from 10 degrees to 50 degrees, but from 10 degrees to maybe 20 degrees, 30 degrees. So the heating on the inlet of the pump is something where we see that it's a necessity to be able to handle this oil. And also the pumping pressure, and that's why we would push for the positive displacement pump, because if we have a longer hose, especially in water, we're going to cool it down again, potentially. So we will need pressure to be able to handle the waxy oil. And then for storage, naturally, we need to consider that using tanks where we can do heating, or then have an open tank where we can actually then, for example, excavate or with mechanical means remove it. But many of these, they are assumptions, and coming actually to the final slide, what next? I really see that there's a lot of testing that we would need to do, and I'm very happy to see that there is a IMAROS 2 project potentially in the pipeline that we need some more work. And for us, for example, one of the bigger challenges have been able to get the fuel, which has this kind of properties in say in reasonable quantities. We don't want to buy 100 cubics of ultra low sulfur oil, but we would need 1 cubic or something enabled to be doing testing, and also doing testing together with for example, CEDR and other entities to try out these tools. So more to prove that are the assumptions correct, and if not, then what can we do? I also do think that we are now looking more on adaptation of the tools itself, not necessarily so much developing something entirely new. I think we do have a lot of tools in our tool pack, but we need just to understand that what the bottlenecks are and how to overcome that. So adaptation of the existing recovery devices is still, I think, one of the paths that we need to go. What comes to the sweeps and trawls, that's something that we would also need to verify at least on smaller scale, because there are assumptions of how they will work, but that needs to be verified. So that needs to be tested. Also in terms of methodology, it's not always necessarily the equipment itself, it's just how we use it and how can we squeeze the oil towards the skimmer, or can we somehow make a move and generate the movement for the oil into the skimmer rather than making a new skimmer that will move towards the oil. So also the methodology of how we operate is something that we need to look into. And then I threw in there as a last, kind of like, would there be something that we could we modify the oil when we need to recover it? Could we spray it with something? Okay, I know that adding chemicals to whatever we want to recover is not really desirable, but if that makes us more successful in recovery, then I think that's something that should be considered. But that was more or less all that I had to present. I had my 4 slides plus 1. So thank you for this.
Thanks very much to Markus, and a reminder that there's a microphone here, and there's also a reminder, a microphone here. I will hand it just to you, Victor, so that you've got it in your hand. And I do have a number of questions here already, because I think everybody's probably having the same thoughts as I am. And mine are relatively layman thoughts, like, wow, how scary is that? Because essentially with this massive proliferation, you've got a whole lot of challenges coming at you from an emergency response perspective. So one of the first questions that I have here from our audience is, are the available capacities at present already sufficient for successful control of a low sulfur oil spill? And if not, when and how best to deal with it? Is that perhaps a question for Torben initially?
Well, the next stage is to find out what is actually useful. And since the variation of those oils is so big, then it may be that we have different types of equipment that are useful towards an oil with these characteristics. So I cannot say whether we have useful tools yet. That is what we need to test and do it in a broad perspective with more producers and with more different types of equipment. And selection systems like speed sweeps, current buster, oil trawl, whatever they're called, they are perhaps useful, but that hasn't been tested yet, and that is hard to test in a test facility. That would probably need live testing, and live testing is of course expensive, but it is a job that has to be done so that we are prepared once it happens. But at the moment, that's not like I have a favorite and give you a small hint on what to bet on, because we haven't seen it yet because of the diversity of the oils.
And this diversity problem that you mentioned, obviously, is there some kind of, has there been contact with the oil companies to actually try and keep you abreast of the changes that they're making to their chemical compositions?
I would like to here credit Shell, because Shell went out with a company name and actually told us you can have oils that are based on our products to test it. So they had the guts to come up front. But a general remark from me would be I'm always suspicious, and that's my nature. Now that it's obvious that oil is blended so much, what reason does the industry then have to tell us about their little products' characteristics? Because since it's mixed up, then they may be there and identified with a not so positive feedback. And that is the problem we'll have when it's mixed up still. So now that you cannot say well, it's because of their product, then what's the reason for them to play ball, to put it that way? But I hope that we could get the same open mindset like Shell demonstrated at this IMAROS project, because that would bring us on, although it will still need to be tested up towards the oil that is indeed used out there and not the oil that is taken directly out of the refinery.
Okay, but at least a step in the right direction.
Yeah,
Thank you very much, Torben. A question perhaps for Victor. Is there a European vision to prevent pollution from these new types of fuels, especially in highly protected marine environments?
Well, it's a very, very broad question.
Indeed.
Is the European vision to prevent pollution? Well, regarding prevention, the European vision is to support mainly the Green Deal and all of the upcoming activities with regard to the reduction of emissions and all the policies of the of the European Commission. So
Indeed.
on that, what we do. And I can talk.
But to take that a step further, based on what we've heard here today, I mean, how could that vision and how could legislation perhaps be?
Well, the legislation has been developed, and there are new packages like the Fit for 55. I mean, the vision of the European institutions is to go for the decarbonization and decarbonization of shipping. So that means that if we succeed. In the future, I mean, there will be less and less fossil fuels in the market. But today, I think this is a bit, I mean, we don't know where we will be in 2030 or in 2040 or in 2050. We have targets, and targets have been set at European level for decarbonization. So
indeed, for decarbonization, and we heard that a lot of these fuels are perhaps less toxic, but that in the event of a spill, they're not as clean upable. So obviously there are places where the new legislations need to be reality tested. Is that what we're seeing here?
I'll draw a comparison about political will. At MEPC, which is a committee under the IMO, there will I think it's in May, there'll be a conference and where they're starting to look into changing the definitions for heavy fuel. And that's because there is going to be a ban of heavy fuel in the Arctic, because that really causes problem to the sensitive environment up there, cold water and all that. So that's a political will to change what is used, because there's a problem you cannot overcome. Until that ban is effective, it was legal to have a scrubber and go by heavy fuel and then just clean your exhaust. But now they say it's still a problem if there is a spill, so therefore we're working on a ban, and I think that would be at the next MEPC meeting in May, if I'm correct. I'm not attending the meetings, but I think I read it somewhere.
Keeping abreast of them, and there will be some movement there. There's another question here for EMSA. If I could just come back to you, Victor. When will EMSA be able to contract an HNS response vessel?
That's a very good question indeed. The answer is okay. It can be very, very much straightforward when there is an agreement and an approval at the governing board of the agency to go for that, and when this is reflected in the budget. So it's not that easy. And also because of the implications in the management of those ships. So we are talking about additional budget, additional resources, and political agreement. And last but not least, it is one HNS vessel for the whole of the EU. I mean, will not solve the issue of the lack of HNS vessels.
Right.
So, yeah, we will be glad to have those, but at the end of the day, I mean, if there is a gap at the European level with one vessel, we cannot fill that gap. And it's not that one of these HNS vessels would have, just to be clear, a similar cost to those availability oil spill response vessels that we have. We are talking about 6 times or 7 times the cost of one of our vessels per year. So there are different modalities of contract, different requirements, and it's much more expensive and technically challenging. We will be happy, but I'm talking by myself because it's part of my work, but we are not there yet.
Okay. Thanks for that answer. There's quite a few questions actually that I think are to be directed at you, but I'll give you a break and go to the other guys here for a moment, because a question regarding research. So there's a question here from a participant. How do you see the involvement and support of civil protection and onshore response stakeholders in the research for suitable and effective equipment for recovering these low sulfur fuel oils, perhaps? Torben, you could say something, and maybe Markus has some thoughts on that as well.
Well, luckily, somebody else had contact with the oil before it reaches the shore, so that there will be some kind toxicity will leave the oil and go out to the atmosphere before it reaches the shoreline. But still, there will be a need to define the personal protection for the responders on the shore. Is it sufficient to have just a rubber dress, or do you need fresh air? And I think the general finding from IMAROS was that fresh air would not, or having compressed air in bottles when you're working there would not be necessary. We also had one other discovery finding for the ship capacities. That is, that none of the oils we received had a flash point below 60 degrees Celsius. And that's important because many response vessels are built to the class notation called oil rec. And oil rec states that the ship should be able to operate in an atmosphere with 60 degrees flash point or higher, so that they cool down the exhaust so we don't create a big bang. Of course, that solves the pollution, but it'll give another problem.
Okay. And Markus, you've got your own microphone,
Yeah,
so.
I would say that in terms of research, then from a business and versus then a governmental. So for us, it's interesting, and like there was in the IMAROS too, that there would be cooperation between manufacturers. I would say that's something that we are interested in. Mm-hmm. Of course, there's always the difference between a business has a business aspect in it, and a governmental has a different attitude towards it. But I do think that this is not that big of a field, so we need to cooperate in order to find suitable tools. So
and are there moves afoot for industry to actually be financially involved in supporting the research to deal with these with these new fuels?
So, could you say?
Can industry actually be financially involved in supporting research into these low sulfur fuels? And are there any moves afoot to elicit that kind of support?
Well, can. I mean, we are having our own development project, but we have our limitations what we can do. But I do think that we would be interested in joining up in testing or verification of what works.
Mm-hmm. And there's a very brief question here for you at LAMOR. What would be your timeline for research? I'm not exactly sure.
Well, we should have started years back already, yes. but this is work in progress. We have on a idea stage and with some trials done testing. We are continuing that has one of the focus points for this year for our R&D. So I would say this year we will put a lot of effort into it, but then also it will take time, and especially getting the oils, getting places where to test, it's not something that easily arranged.
Mm-hmm. Another question coming in from the community here. Victor, I'm going to put this one to you. Would standardizing, I think this is what we were trying to get at earlier with my earlier question that was somewhat more vague. Would standardizing or regulating the composition of such new fuels be a feasible approach? I mean, we're always standardizing and regulating. I mean, the IMO regulation is one of those new regulations, but has, again, a whole set of implications. So how do you see that?
Well, that question is also very difficult because actually, I think it refers to the chemical composition.
To the chemical composition
Of the fuels, of the low sulfur fuels, and one of the beauties of the low sulfur fuels is that there are no two low sulfur fuels equal, because they are the result of a blending of a number of things, and you don't have the same product in the refinery in Sweden and in the refinery in Spain. So it is a proposal that as I see it, in principle, unrealistic, because otherwise there will not be a low sulfur fuel. I mean, we can standardize the composition of something that is coming from a regular process of if we start with oil and we have different phases. I mean, those products that are the result of the decantation of oil or the process of getting gas oil, gasoline. I mean, this kind of products. But this is a mix of oil, fuel oil, chemicals. So I think it's from a technical point of view, or even from a political point of view, is a difficult thing. And then at the practical implementation, very, very challenging, as I said.
And a question maybe to both of you, what are the implications in terms of training then for the various bodies, the marine and shoreline recovery, the various response units? If this continuous fluctuation and you're constantly sort of, it's a bit of a luck of the draw, what kind of a substance and a chemical composition you're actually going to get. Can you say something about that, Markus?
Yeah, I could comment on that. I think both this low sulfur, but also as well as HNS, I think it's a lot about training and know-how. I mean, you're talking about getting a vessel for HNS. A lot of this HNS combating is more or less knowing how to protect and not cause bigger damages, not necessarily recover. So I would say the knowledge of how to handle is a key issue. So
knowledge of how to handle and how to protect, but also how to identify, right?
True, that as well, yeah. And I think that's both on the especially on the HNS side. I would think there's so huge difference of chemicals out there that are being transported. Low sulfur oil, I would say that once you see it getting solidified, that's it. Then you know that it's solidified, and then you just need to act accordingly. But knowing what to do then is something that we need to. First, we need to understand what would be the ways to do it, but then to share that information. So not necessarily only tools, but this know-how.
Okay, thanks very much. Torben, how about this one for you? Are there best practices? You mentioned Asia. Are there best practices for technologies and methods for the containment of low sulfur oil spills in other regions of the world? And how much are you looking abroad or traveling abroad to see how other areas are dealing with this issue?
I've attended for several years a forum called North Atlantic Coast Guard Forum. And the first question I'm asked is, how is it going with the research on low sulfur fuels when I meet with my Canadian and my US colleagues? There was IMSA in Australia had quite a good report. I think it was in 2019. Australia is also looking into the research, but very many are looking towards Europe for this one.
To be a leader in this.
Yeah, but also because we can bring together so many competences and also because there has been a tradition for mapping very many trends in Europe. So this thing about that the European Arctic Council countries sit down and say, let's map where the oil used in the Arctic actually originates from, and finding out that 32% is shipped out in Singapore. That's a discovery you wouldn't do if you just start looking at that specific problem. You need to have a culture of mapping and investigating whatever is going on, because then you have the footstep for dealing with research like combating low sulfur fuels. And that we have a track record that is quite good in Europe, and the other nations may be more isolated and cannot to refer to the same culture.
And does that leadership position, how does that translate then in terms of dealing with areas like, for instance, the Americas, where a lot of legislation is changing now, a lot of protectionist issues are happening? How open is the communication, I guess I want to know, between sort of first responder communities there and here?
I think that when you found out what works, then it'll be a worldwide discovery. And then I don't know, LAMOR, do you have a department in the US? Desmi from Denmark, I know have. So it'll be as soon as one of the European companies has the solution, then that solution will be adapted by anyone within the industry, because you need some kind of proven effectiveness to be the one that could sell your equipment. So okay. Therefore, as soon as we find out what's working, they'll all have it. Because the equipment is quite cheap to produce. It's the research that is expensive.
Okay. So then a technical question, thank you for that, and a technical question here that I think goes to you, Markus. Does shoreline cleaning with hot water cause damage to organisms in porous rocks?
As far as I know, yes. I mean, there is a risk of that one as well. So you're also killing whatever is on the surface of the rocks and stones. So I would say it's one method. You always need to think on the bigger picture, that how do you cause the smallest impact in your recovery, and sometimes you need to sacrifice some parts. But yeah, I would say that hot water also, it's not the solution everywhere.
Thanks for that. Perhaps just a sort of a tour de table with the final takeaways. Victor, how will you come away from this gathering, and what will you have taken with you from the discussions here today as to how this can be taken into the right direction? And of course, obviously, with things taking time, research takes time, it's expensive, the costs are huge. But, and we know costs are an issue now because we've got a geopolitical situation, which means that investment is being poured into other directions. Yes. And yet we realize with issues like Turkey, with issues like Greece, and all of the various maritime issues, that we always need to be able to expect, even though we don't want to expect them, that these kinds of investments that we heard necessary from the group discussions this morning are key and very, very important. So what are your thoughts?
Okay, let's try to put the things in a smaller cycle, because you started too broad, I think. The first takeaway from the participation in this exercise is very positive. I think I've seen 50 participants from many
14 countries.
Member states with a very active participation.
Yeah.
So that means that there are topics of interest. There is commitment from the people, but there are also, I would say, some gaps identified that will be later on maybe discussed or evaluated. Maybe it's too early now. We are just at the fourth day of the event, but that is very positive if we at the different levels. Of course, not all nations have the same level of commitment or preparedness or financial resources, but if we have all a common understanding that there are some gaps to be filled at national or at the European level, and I think on that we are all on the same page. Also, I think we agree here, and we have a vision on the challenges that we experience now, the current challenges and future challenges. HNS response to chemicals, the low sulfur fuels we have discussed extensively this afternoon, and in future also about these alternative fuels. Regarding the match of the geopolitical situation with this
You don't need to go into that in depth.
If you allow
Simply
me,
an observation.
maybe my colleagues, but I will not enter into that. And yeah, I think just to conclude, I think this model of discussion base brought good and interesting discussions, but also from some discussions with some colleagues here with the Commission, I think, in my view, I think we are trying to foster or to deepen into cooperation
Between
at the
member states.
European level.
Yeah.
So from the Commission or from EMSA to have a better integration and operational cooperation with them, but it is also, I think, finding here or an element identified in many member states that maybe we should do the same exercise internally, because we try to establish this cooperation that flows smoothly from the European Union to member states, and to identify how can we better communicate, how can we integrate, who is responsible here and there. And then maybe we have to look a bit also internally and see how we have our national structures. We all have national structures at the end of the day, regardless if we work for the Commission or for EMSA or for a member state, but this is about...
So certainly a lot of awareness raising of the challenges, and this has been very fruitful. Torben, vielleicht just a quick word, maybe just a quick word, and a quick word from Markus as well, in terms of your takeaways.
It's hard to do this shortly, but I have three main takeaways. First is information sharing. A maritime incident starts under DG Move in the Commission. It's traffic, it's safety at sea, it's the communication means here is SafeSeaNet. Then when you need help from each other, then you go into CESIS, that is the civil protection mechanism, that's DG Eco. When you have done all your cleanup and you need to calculate what were the environmental consequences, then you're on DG Environment. I would like that we all stick to the same platform and access point for our information, and that should be under EMSA, because that is also where the civil protection community can go directly in and see this is the latest satellite update on the pollution, this is where I have to protect my coastline tomorrow. That's one thing. Then the other thing is this course has been fantastic because it has merged together personnel dealing with 4 phases. First, when you start alerting, then rescuing people, then pollution response at sea, and then the environment. This is a new type of course, but we still need courses that are hardcore environmental response courses for the seafarers, and that's like the Tech MI we had. That's my second one. The third one is a lack of standardization, because right now there's no manual for claims, building your claims case. If we could get a standard of that, then the discussion between PNI and the member states will not be about what process you use, but about the input when you say you have to pay me so much money. That's the same goes for a standard for actually the environmental assessment past a significant acute pollution, like it's called in the European Maritime Strategy Framework Directive, Descriptor 8, where we have an obligation as member states to calculate the consequences of a big spill. So that was a short summary of my takeaways.
Thank you very much, and I'm sure the audience has appreciated hearing that. Markus,
Well,
final word from you.
I will try to keep it to just a few words, and having only been here today, but I think the bringing up or raising the awareness of a certain aspect is important, and then sharing the information. So I think, was it Rolfo who said that capitalizing the know-how or something like this? I think this is the key. One single entity will have difficulty in solving these issues, but together with the shared information, I do think we can.
Couple of positive steps made. Thank you very much, Markus Nystedt, Torben Iversen, and Victor Diaz. Thank you for sharing your wisdom here on stage. And we have a coffee break for all of our participants here in the room. We're just after 15:15, so I'll see you back here at 15:45. That's just under 30 minutes. Go get some caffeine.